So today we'll be talking about determining the equation of a cubic function. What we want to do is take a graph, a cubic graph, and change it into a cubic equation. We're going to be trying out two examples of this, and then at the end of this, you should have a better understanding of how it works. Let's get into it. So this question here says find the equation of fx, which is equals to ax cubed plus bx squared plus cx plus d. Now we see we're given a cubic graph where the x-intercepts are given and we have a y-intercept. Now to answer this question, the first thing we see is the question was given in the standard cubic equation. We need to write it in the x-intercept cubic form to start with. And this form is now x1, x2, and x3 represents the x-intercepts we see in our cubic function. So what we just need to do is substitute these values into the equation. Now we see we have an unknown, which is a. To find this, we need to substitute another point that isn't our x-intercept. So we're going to substitute 30, which is our y-intercepts, 0 and 30 into this equation. So it helps us find our value for a. So as we see, a is equals to 1. So going back to the equation, we write. So all we just need to do is expand. Let's start with the first two brackets. Then we expand one more time. And this would be the equation of our cubic function. This is exactly how you can have your cubic graph and you're given your values for your x-intercepts and you can convert it into a cubic equation. That's it. Now this question gives us the equation of gx, which is negative 2x cubed plus bx squared plus cx plus d. And we're also given the graph of gx, and on the graph of gx we can see two turning points. The first turning point is 2 and negative 9, while the second turning point is 5 and 18. The question asks us to find b, c, and d. To find this, the first thing you can do is to get the derivative of this equation. So the derivative of g prime x would be. Now, the reason why I did this first is because our turning point for a cubic function is normally calculated by saying that the derivative is equals to 0. So what this actually means, our g2, which is the x coordinate of the first turning point, and is also going to be g prime 5 is equals to 0. Now, one thing you would also notice from our derivative equation is that when you derive a cubic function, the derivative is usually a parabola. If you have a negative cubic function, it forms a negative parabola. So what I mean by that, if you can just sketch what would happen, we are saying that this here would be the derivative of gx. Our turning points that we do get from the original gx equation would be the new x-intercept for the derivative, meaning that this point here would be 2 and this point here would be 5. Now whenever you have a parabola and you're given the x-intercept and you're trying to find the equation of your parabola, we normally use the x-intercept form. So meaning that we're going to say, now substituting your x-intercept, now the good thing is that from our derivative that we found, from the original gx, we see here that our a is actually negative 6. So we don't need to find a in this equation since we know what it is. Comparing it with the original derivative that we have, which was negative 6x squared plus 2bx plus c. Now we can use that to help us find our value for b and also help us find our value for c. So you take this part and that part. Equating them, you'll get and for c, we would also take that part. Literally just means c is equals to negative 60. We have b, we have c, so what is left is d. So now let's rewrite our equation one more time. So to find d, all we just need to do is substitute one of the coordinates of our turning point that we have in the original equation. So take, for instance, let's substitute 2 and negative 9 into this equation. So therefore our value for gx would be So this is exactly how you find the question, where you're given the turning points and you need to get the equation of our cubic graph. That's it.